Hello, I'm Jesse Reynolds.
And I'm Callie Creason, and we are going to talk about the Campbellsville University Organic Chemistry IR Spectroscopy Lab.
As for the introduction section, infrared spectroscopy and mass spectroscopy will be studied. Infrared spectroscopy is the analysis of infrared light that interacts with a molecule. It measures vibrations of atoms which allow for the determination of functional groups. This is not to be confused with mass spectroscopy, which is a technique that helps identify the amount and type of chemicals present in the sample by measuring the mass to charge ratio. The objective of this experiment is to study the given list of unknown samples, and off of this list, the structures of two unknown liquids and one solid will be determined using infrared spectroscopy. The procedure for this process was relatively simple. First, an unknown liquid was obtained, and 2 drops of the unknown was placed on a salt plate. After running a blank in the spectrometer, the salt plate with the 2 drops of the unknown liquid was ran. This presented a graph, and it was converted to percent transmittance, and the peaks were then able to be recorded. This process was again repeated with the second unknown, except there was no salt plate used. Finally, the process was done again for an unknown solid.
That was obtained from the IR spectrometer when we ran the test for the unknown liquid L. This is an extension of the results from the run on the unknown L1. There were major peaks that were obtained and seen at 3000, which is an S or a CsP3 to an H group. There was a 1700, which is a C double bond to a C, and there was a 1600, which was seen to be as an aromatic ring. The structure of this can be seen to the right, and then the identification of this unknown was deemed to be bromobenzene. This is the graph that was obtained from the IR spectrometer when we ran the test for the unknown L9. For the unknown L9, there were major peaks observed at 3100, which was deemed to be an OH group. There was one at 1650, which is a C double bond to a C. There was one at 2400, which is a C sp3 to an H group, and then there was one at 1600, which was an aromatic ring. The structure for this L9 can be seen to the right, and it was determined to be benzyl alcohol. This last graph is what was obtained from the IR spectrometer when we ran the unknown solid that was S2. The major peaks that were observed for the unknown S2 were at 3000, which was either a C sp3 group or an sp2 group bonded to an H. It could be either one. There was one observed at 1650, which is a C double bond to a C, and then lastly there was one at 1500, which was deemed to be an aromatic ring or multiple aromatic rings. The identification of the unknown was determined to be anthracene, and the structure can be seen to the right. Again, the objective of the experiment was to determine the identity and structure of two unknown liquids and an unknown solid from a given list of unknowns. Based on the information that we got from the IR spectrometer, the first unknown was determined to be bromobenzene, the second was benzyl alcohol, and the third solid was anthracene. Although the IR data was likely accurate because we used the machine that is in the lab, the analysis was difficult at some times. Some of the peaks were higher or lower than what we really wanted, and sometimes they were at a different wave number than what was needed to determine that it was an OH group, a CC double bond, what have you. The experiment was deemed successful because we did identify the structures and the identities of all three of the unknowns, and we became familiar with the use of the IR spectrometer, and all the goals of the experiment were reached, but the analysis may or may not have been quite as accurate as what was wanted.
Here are the references that we use in this experiment. The first one comes from Kim Swider. The next two are just some random websites we use to help us understand infrared and mass spectroscopy. And then the last one is a list of the unknowns that came from our very own Dr. Mullins. Anyway, this concludes our experiment, and we hope that you were able to learn something, and we appreciate your time. Thank you.